Some important questions from differentiation. Question number one. Y equal to twice of root what x square by dx equal to 2 upon 2 root what x square into d upon dx of what x square. That will give minus 2 cosec square x square. Then derivative of x square will give 2x divided by 4 x square. Now, this two will cancel out. We can write cosec square x square in denominator as sine square x square. Then 2x with a negative sign. This cot x square can be written as root cos x square divided by root sine x square times. This will become 1 upon sine square x square. So we can write it sine x square times root of sine x square times root of sine x square. So 1 sine x square will cancel out, and we can take sine x square cos x square inside the square root, and we can multiply by 2. So minus 2 root 2x divided by 2 into cos x square into sine x square times sine x square. And this is formula of sine 2 theta. So we will get dy by dx equal to minus 2 root 2 x divided by root sine 2 x square times sine x square. I think you must have understood. Here, this cosec square x square is written in denominator as 1 upon sine square x square. Then this sine square x square is split into 1 upon sine x square into 1 upon sine x square. Then this sine x square is written as root sine x square times root sine x square. And then this root sine x square is cancelled with this. Rest is clear. Now let's take next question. Question number 2. Y equal to root of e power root x. Now we can square it. So y square will be equal to e power. Now we differentiate it. 2 by dy by dx will be equal to e power root x times derivative of root x d upon dx of root x. So it gives 2 by dy by dx equal to e power root x divided by 2 root x. Now dy by dx equal to e power root x divided by 2y times 2 root x. But y is square root of e power root x. So 1 upon 4 e power root x divided by root x times root of e power root x. We can put this root x and e power root x together. So 1 upon 4 e to the power root x divided by root of x times e power root x. Which is our answer. Now let's see next question. y equal to sine inverse x. We have to prove that 1 minus x square times y2 means second derivative minus x y1 equal to 0. So let's find out dy by dx, which is equal to y1 equal to 1 upon root of 1 minus x square. Now we find second derivative, that is y2 will be equal to d upon dx of 1 minus x square whole power minus half. Then we apply formula d upon dx of function power n, that becomes n function n minus 1 times d upon dx of function. So y2 will be equal to minus 1 by 2, 1 minus x square power minus 3y2 times d upon dx of 1 minus x square. That will give minus 2x. So minus 2x divided by, this will give minus 2x, and there is already minus sign, divided by 2 times 1 minus x square whole power minus 3 by 2. So 2 will cancel out and this will become plus. So we will get x divided by 1 minus x square whole power minus, this minus power will become plus, plus 3 by. Now 3 by 2 can be written as, like suppose we have x power 3 by 2, we can write it x into x power half. So we will get y2 equal to x divided by 1 minus x square times root of 1 minus x square. But y1 equal to 1 upon root of 1 minus x square. So we can write it as y1, this term. So, and we can multiply 1 minus x square to r's. So we get y2 times 1 minus x square equal to x times y1. We can shift this to LHS. So y2 times 1 minus x square minus xy1 equal to 0, which was our values. Now let's go to next question. Question number 4. Question number 4 says we are given y equal to sine inverse x plus sine inverse root of 1 minus x square. We have to find out dy by dx. So dy by dx equal to 1 upon root of 1 minus x square plus, same rule we apply here, d upon dx of sine inverse f becomes 1 upon root of 1 minus f square into d upon dx of f. This f is a function. So here it will become 1 upon root of 1 minus x square whole square. So here it was in a root 1 minus x square, and then d upon dx of root 1 minus x square. So 1 upon the root of 1 minus x square plus 1 upon, this will become 1 minus 1 plus x square. Because of this square, this root will get cancelled into derivative of this will become 1 upon 2 root 1 minus x square times minus 2x. Now we further simplify. So from here 1 upon root of 1 minus x square, and this will become 1 upon 1 will cancel out, root x square will give x, and this 2 will cancel out. So here we will get minus x divided by root of 1 minus x square. This x will cancel out. So we will get 1 upon root of 1 minus x square minus 1 upon root of 1 minus x square. That will give 0. Now, let's see next question. Question number 5. Question 5 says, if we are given x root of 1 plus y plus y root of 1 plus x equal to 0, then we have to prove that dy by dx equals negative 1 upon 1 plus x whole square. Let's see how. So x root 1 plus y plus y root 1 plus x equal to 0. We shift this to system to RHS and then square it. So we get x root 1 plus y equal to negative y root 1 plus x. Squaring both sides, x square 1 plus y equal to y square 1 plus x. We get x square plus x square y minus y square minus y square x equal to 0. From these two, we can write x minus y x plus y, x plus y, and from these two, we can take xy common, xy common, then x minus y equal to 0. So x minus y will be common throughout, but x minus y does not equal to 0. So what we get? X plus y plus xy equal to 0. So now we have to differentiate this equation. So let's differentiate it. So 1 plus dy by dx plus, here we apply product rule. So x dy by dx plus y equal to 0. From where we get dy by dx common. So 1 plus x and 1 plus y we shift to just with negative sign minus 1 plus y. So we have got dy by dx equal to minus 1 plus y divided by 1 plus x. Now, what we can do? We can get the value of y from here or directly 1 plus y. So let's see. We are given x plus y plus xy equal to 0. So, so here x plus y plus xy equal to 0, and our purpose is to get y. So it gives x plus y common, 1 plus x equal to 0, or y equal to minus x upon 1 plus x. Now we put the value of y here. So what do we get? We get dy by dx equals minus 1 plus minus x upon 1 plus x, value of y, whole divided by 1 plus x. Take LCM. So minus 1 plus x minus x divided by 1 plus x, whole divided by 1 plus x. X will cancel out. We will get minus 1 upon 1 plus x from here and 1 plus x from here, whole square, which is our answer. Now, let's see next question. Question number 6. We are given y equal to cot inverse root of 1 plus sine x plus root of 1 minus sine x divided by root of 1 plus sine x minus root of 1 minus sine x. Now what we can do is we can visualize this term. So for that purpose, we write it cot inverse 1 plus sine x plus root 1 minus sine x divided by root 1 plus sine x minus root 1 minus sine x times root 1 plus sine x plus root 1 minus sine x divided by root 1 plus sine x plus root 1 minus sine x. Now, it will become y equal to cot inverse. Numerator will become a plus b whole square. So that will give 1 plus sine x plus 1 minus sine x plus 2ab. That is twice of root of 1 plus sine x multiplied by 1 minus sine x, and that will become 1 minus sine square x, and that will give ultimately cos x. And here it will become a minus b, a plus b, so that will become 1 plus sine x minus 1 minus sine x. Now we further write y equal to cot inverse. Here sine x will cancel out, and this will become 1 minus sine square x, and that will be cos square x inside under root. When under root is removed, it will become cos x, and what becomes 2. So 2 plus 2 cos x divided by, when we open the bracket, 1 will get cancelled, and 2 sine x will be left. So we get y equal to cot inverse. If you take common 2, and then this 2 will get cancelled. So 1 plus cos x divided by sine x. Now, our next step will be y equal to cot inverse 1 plus cos x divided by sine x. We know that cos 2 theta equal to 2 cos square theta minus 1. So if we put theta as theta by 2, so we get cos theta equal to 2 cos square theta by 2 minus 1. Similarly, sine 2 theta equal to 2 sine theta cos theta. If we replace theta by 2, then this will become sine theta equal to 2 sine theta by 2 cos theta by 2. So we can put these values here. So y equal to cot inverse 1 plus 2 cos square x by 2 minus 1 divided by 2 sine x by 2 cos x by 2. Now 1 will cancel out, and then this 2 will also get cancelled, and 1 cos will also get cancelled. So we will get cot inverse cos x by 2 divided by sine x by 2, which becomes y equal to cot inverse cot x by 2, and that will become y equal to x by 2. Now we find dy by dx, dy by dx equal to 1 by 2, which is our answer. Thank you for watching.